Hey everybody, welcome back to our video. We're going to talk about inverse functions today, and this is going to be basically how we can tell if something is an inverse function, how we can find the inverse functions, and then some basic application of the inverse functions as well. So let's get started. Now, in order to tell what an inverse function is, a really basic example would be an egg. Okay, so imagine that you are going to dye an egg, just like you might for Easter. You're going to take a white egg, that's your X, okay, and you're going to put it into a colored dye, maybe in this case blue. That's your function. So the function is your dye, and the result is your Y value, which in this case, if you're putting a white egg into blue dye, you're going to get a blue egg. Okay, so here's our little image, putting an egg into the dye, and it comes out a different color. Okay, well, an inverse function undoes that. So if you're dyeing eggs, then the inverse would be bleaching them, because it's going to take that dark color and it's going to make it go backwards. It's going to turn it back into white the way it started. Okay, so we put something in and it comes back out white. Okay, so think of inverse functions like that. It's going to undo something. So when we're talking about inverse functions, let's take a look at this really basic example of a square root function. An x squared function. Well, if we have basically three or four parts to this, we have the x value. Let's say we have x equals 3. If we plug into our function, so we plug into the x squared, that gets us 9. Okay, so that right there is the example of the egg. We took an egg, we put it in the dye, and we get something new out. So I took my x, I plugged it in, and I get something new out. The inverse would be the opposite of that. Well, how do we undo an x squared function? Well, we take the square root. So we would take the 9, the answer we get, plug it into the inverse, and what we get back is the original answer. Okay, so these two things undo each other, so we get the same original numbers. If we're looking at ordered pairs with inverse functions, it's really easy. Basically, if I give you a point and I want you to find the inverse of that, you're just going to switch the x and y value. So here it says the point is 4, 7. So if I want to find the inverse of that, then it would be 7, 4. And you could go ahead and plot it. And the same over there for negative 5, 3. Then we would have the inverse, which would be 3, negative 5. Okay, signs don't change, just switching the x and y value. So that should be really, really simple if you're asked to graph points, or in general, if you graph an equation and you need to graph the inverse, just switch all the ordered pairs you have from the original graph. Okay, so here's another example. You don't have to necessarily draw this, I just want you to look. We've got a function, and it's just a random function. We don't know what it is, and it has these 5 points in it. So 0, 1, 2, or 1, 2, 2, 4, 3, 8, 4, 16. And we would plot those, and if I wanted to find the inverse of that, I would just switch all my x's and y's. So now I would have 1, 0, 2, 1, 4, 2, 8, 3, 16, 4. And notice this is what it would look like over here on the graph with the blue and yellow dots. The blue would be your original, the yellow would be your original, the blue would be your inverse. And what you should notice, hopefully, is that there is a line of reflection, and this line of reflection is the same for almost every inverse function that we're going to deal with in this chapter. So notice I drew it right down the middle, and that it's like basically flipping over that line. Well, what is that line? That line is our y equals x equation. So that's just a basic line. You should know that from how to graph that from Algebra 1 or even before. Sorry, my dog's barking. So every inverse function is going to be reflected across this line. Well, if we want to take an inverse function and we want to figure out that, or two equations, and we want to figure out if they're inverse functions, it's very simple, and this is where you're going to use composite functions from section 3. Basically, you're going to take two equations, and you're going to show that if you plug the inverse into the original, you're going to get x out, and if you plug the original into the inverse, you get x as well. So you're plugging equations in, okay, and we're going to go back to this example here in a minute, but I just want you to write that down, that if you want to verify that if two equations are inverse functions, you're going to have to use composition. So inverse into the original to get x, and then the original into the inverse, solve and get x. Alright, so here's a really basic example. We're going to practice finding inverse functions first, and then we'll go back to testing. So here we have y equals 6x minus 12. If you want to find the inverse of this equation, there's basically two steps you have to do. The first one is to switch your x and y before you start anything. So in this case, we'd have x equals 6y minus 12. So all I did is switch places. I didn't move anything else but the x and y. Once you've done that, the next step is just to get y by itself again. So you're going to solve for y to get it on its own. And I've done that here in these steps. So we had our original equation. I added 12 to the other side here. And then to get y by itself, the last step is to divide by 6. Now, if you want to leave it like this, that's fine. But if you want to break it up, it looks a little bit more familiar when we write 1/6 x plus 2 equals y. So this function right here at the bottom is the inverse of my original function. Alright, and we could test this by plugging in my inverse into the original, and I should get that y equals x. And if I take the original and plug it into my new inverse function, then I should get y equals x as well. So I want you guys to go ahead and try this function on your own. Press the pause button. Remember, switch your x's and y's, and then get y by itself. Alright, so remember we switch our x's and y's, so when you switched it, you should have gotten this. And then, when you solved, now I've done all this out on one big step, you're going to subtract 2 over to get the 3y squared by itself, then divide by 3, and then remember to get rid of a square, we take the square root of both sides. And it is the square root of that whole fraction, not just the top, so make sure you do that. That you write the square root x minus 2 over 3. And be very precise in how you write these. Make sure it's easy for me to read. I don't want to have to try to guess what you're writing. Okay, now inverse functions, these are just two very common examples where we have an x squared equation on the left and its inverse is x equals y squared, so we just switch the x and y. Notice there's still parabola shapes. The blue is the original, the red is the inverse, and they're still reflected across that y equals x axis. Okay, and the same thing over here, my blue line, that's kind of this curvy shape here, that is my y equals x cubed function, and then the red that kind of looks like a really stretched out s, that's my cube root function, which is the inverse of x cubed. So, the key is that you want to pay attention to if your new functions, in red in this case, but on your papers, if they're actually functions or not. So notice that in these two pictures here, the original functions, the original equations, the original graphs are all functions, but when you take the inverse and graph the inverse is no longer a function. And the way we can tell that is if it passes this horizontal line test. So what you're going to do is you're going to graph an equation, its original equation. Okay, so if I give you y equals x squared, you'd graph that equation, and then you're going to see if the horizontal line test works. Remember, horizontal line test works that if you can draw a horizontal line through any place on the graph and it only hits at one point, then that means its inverse will be a function. So that's the example over here on the left. Okay, the horizontal line test passes, it only hits one point. So that means if I were to graph the inverse of this blue line, I would get a function. But if we have an original function that does not pass the horizontal line test, okay, so you draw this line straight through and it hits more than once, that means the inverse that you would draw later, so remember my parabola was off to the side, that one would not be a function. Okay, that doesn't mean you can't graph it, it just means it's not a function. Alright, so like we said, we can graph these, we can find the inverses and then graph them. So here's an equation. It says f of x equals x to the 6th when x is greater than or equal to 0. So there's a restriction there, so that means when you go to graph it, you're not going to have anything less than 0. So what we're going to do is first find the inverse. Okay, so remember this is where we switch the x's and y's, so we'd have x equals y to the 6th. And then we're going to solve for y. So to get rid of the 6th power, I'm going to take the 6th root of it. So I'd have the 6th root of x equals y. Now that's not something we typically know how to graph. So for now, until we get into our later problems, it's okay to either make a table of values, which you just have to get a calculator out because we don't know 6th roots, or go to Desmos and try to graph that. Just know that on a test, you're not going to have Desmos, so try to graph with a calculator or a table and plugging in numbers as much as you can, and just be able to rely on that versus the computer. But I went ahead and graphed this one on the computer, and so what you should notice is this dark line is our original, okay, and then the inverse is that light blue, sorry, that light gray color. It may be hard to see for you guys, but it's reflected across this y equals x line, so there's our new functions. Now, how we can use inverse for application problems is really useful. If we want to find any predictions, it says the average price, which is P, for an MLB ticket can be modeled by this equation. So we've got P equals 10.7 T to the 0.272. And it says where T is the number of years since 1995. So what they want you to do is write the inverse of this function and then figure out what year the average ticket price is going to be $25. Okay, so first find the inverse, and then find the year when the price is $25. So we're going to go ahead and do this. First, in finding the inverse, here's our original equation. We switch P and T, that's just like X and Y. So we get T equals 10.7 P to the 0.272. So of course we're going to be, typically we would solve for P, but in this case we're going to stop here because they tell us what the price is, and we're trying to predict something. So in this case, 10.7 times what? Well, the price they said was 25, so we're going to plug in 25 there. And then this is all just calculator work. So once you plug in your calculator this 25, you would get 10.7 times 2.4. Please make sure you do the exponents and then multiply by 10.7. Do not multiply 10.7 times 25 first. Okay, that's not the order of operations that we want to use. Okay, and then we multiply that out and we get 25.68, and you're done. So pretty simple application. You just got to be able to find inverse. If you have any questions, please let me know. You guys should be good to go ahead and start your assignment. Thanks for listening.